And welcome, everybody. My name is Will Hadding. I'm a DE for Capital One.
And hi, everybody. My name is Tanu McCabe. I'm also a DE, or Distinguished Engineer and Architect at Capital One. And today we are here to talk to you about serverless at scale. Just a quick show of hands. How many people in here are already running serverless workloads? Quite a few. And you still hope to learn something from us? I'm flattered. So today's agenda, we're just going to walk through what is serverless from our perspective, and then a few patterns that we've implemented at Capital One, partnering with various engineering teams, and then the conclusion, which is really going to be, if you happen to take a nap during this whole session, what do we want you to walk away with? And with that, what is serverless? So from our perspective, any managed service can be serverless if these three characteristics apply. So the first one, quite simply, if there are no servers that you directly have to administer. Second, the service scales automatically and is highly available. And third, that there's a pay-as-you-go charging model. Now, a few years ago, when I first embarked on my serverless journey, I got really excited about serverless. And I started explaining this to my daughter, who was about 5 years old at the time. And I went on and on, serverless is so cool, it's going to be nirvana, blah, blah, blah. And she looks at me and she goes, "Mommy, it's just like cleaning." I was like, "Cleaning?" And she's like, "Yeah, when my room gets cleaned without me even noticing, and I don't have to pay for it." I was like, "Well, let's talk about chores." But if you go by this definition, what we realized is there's a whole world of serverless offerings that are available for you. And at Capital One, one thing we tried to do is figure out for various use cases, how can serverless apply? This is not an exhaustive list of serverless offerings, but it is a representative list of various serverless offerings from Amazon. And the takeaway here is we want you to understand that you can use serverless in various combinations to support various use cases, not just web-based applications, but also real-time analytics and data processing. One of the challenges we had at Capital One when we embarked on our serverless journey is how do we make sustainable patterns that are feasible at scale. So Capital One, just to give you an idea, is rather complex. We have thousands of environments, high volume of data, and this type of scale brings us interesting problems to have to solve. So with that, I'm going to turn it over to Will, who's going to walk us through some of the patterns.
Awesome, thanks, Tanu. Some of the stuff that we've been working through, and I'll touch base on a couple of things that we've touched on over the last year, some of the stuff that actually came from reInvent 2018. From an event-based architecture perspective, though, it suits serverless. You get your asynchronous call that enables your decoupled systems. It enables immutable and persistent shareable events, and it's highly resistant to failure, right? You don't have to worry about managing systems. You don't have to worry about rehydrating systems over X amount of time. All of the actual systems are there for you. And from a server-based perspective, where everything used to be very much coupled, you are now in a system where everything is decoupled. So when we look at it from a release perspective, you have your producers that can be released at any given time by itself. You do have to take into account your consumers that would actually still consume from the event store or the events that is driven at this point in time. But those items can also then be released on its own. So moving forward from this one, let me see, lost my, so one of the other points on this slide before I move forward, the highly observable and extensible system. One of the things that we did find is from a event-driven system or from a Lambda-driven system, anything in the serverless ecosystem, some of the things that we've noticed is there's not always enough of a observable system, right? So you do still have to build some tooling in order to see, do you provide enough logging? Do you provide certain tracing within your application so that you can find stuff? The cloud metrics and the cloud logs and everything else that's there do provide you a wealth of knowledge. But if you're trying to look through items like latency, right? It does show you from a logging perspective that something ran at X time and it ended at X time. But in between those times, you have no idea what's there. So you have to make sure that you build something at that point in time into your application to provide you the details that's there. This one I'm very passionate about. As I mentioned earlier, 2018, AWS in their ALBs actually did provide a new function for the ALB so that Lambda functions can be invoked. So at Capital One at the time, we had an issue. So we are a bank, so we do like to keep stuff private now and then. We have a lot of internal static websites, whether it be documentation, it's the same as everybody else everywhere, right? The problem, though, at that point in time is we had the Nginx's, the Apaches, you had your EC2 servers, your autoscaling groups, everything else. We had to still manually handle all of those, the rehydrations, everything else for the servers, to patch them for vulnerabilities and so forth. That is a huge effort, right? So when AWS released Lambda functions as a invocable function, we started working on this. So the intent behind it was to basically say, okay, all of our engineers that do Angular or any of the static website hosting or any of those types of frameworks, this can really help them, right? Because it allows us to say, okay, we have now created essentially an Nginx that runs in Lambda, but there is no servers. Some of the issues that we quickly ran into is ALBs have limits, right? You have a 1 meg throughput at any given time that you can push over the wire. So if you have a JSON file that you're trying to read off of S3, if it's higher than 1 meg, you're not pushing it through. Same thing for images. Images are a little bit more complex, but we'll touch on that in a second. With the images, the same thing. If you have large raw images that you traditionally use in your static website and you're trying to render them through the same front end, you're going to run into problems because it's too big. You just can't get it through. One of the next point there is streaming is not available. And the reason why I mentioned that a ALB essentially uses a structure. And so the JSON structure normally, depending on what language you're using. And that is returned to the ALB that then reads this and responds to the client based on the headers and the body that's there. The problem with that approach is if you're looking at traditional web servers like Nginx, Apache, and so forth, you could traditionally read off of the wire and IO copy directly over the wire for your client that's actually reading the data at that point in time. That, unfortunately, is not available. So you end up with a buffered approach. But depending on what language you're using, you can still overcome some of the deficiencies that you have from this by doing concurrent pulls from all of your blocks that's over there. On the S3 side, it depends on your actual use case, though, and deliver those in smaller chunks. One of the big things that we ended up building into the application, and application does use Go. So we built it out in multiple different languages at first. Go ended up being the most effective or the best tool for the job, mainly because it has effective gzip. It has the way it handles certain things works a lot better than, or easier, I should say, for our use case based on what we try to accomplish. Gzip is a favorite from that perspective, mainly because we could get a 14 meg JavaScript file, uncompressed, gzipped over the wire and still render that to a client. So, which is a huge thing to have, especially if you're doing big Angular applications where you have 5, 6 meg bundled JavaScript files. Next point on there was the hot Lambda share memory. And we'll touch on some of the additional things that's an outlier from this. But if you're building an actual Lambda and you're using it like we are as a web server, you have certain configuration that you want to load into the actual server itself, you may have to store that somewhere. And effectively, if you have a really good website that everybody is interested in and they're hitting it all at the same time, it's a huge amount of load, right? that you are actually going to distribute to the backend or from your configuration. So an effective way of doing that is to basically take your memory. So whenever there's a hot Lambda, I'm not sure how many here are familiar with what a hot Lambda is, but it's essentially if you hit a Lambda, it runs, and then AWS essentially puts it to sleep at that point in time for a small duration. On the next request that essentially comes in, it just starts up the same Lambda at that point in time, so you still have your memory at that point in time. So you can reference building in your application, you can say, okay, if my memory is currently available, just use it. That way I don't have to go to my backend where I store my configuration data, whether it is environment variables or a secure system to pull your actual data out of. This also touches on the caching that reduces calls, right? Because you're using the shared memory at that point in time, you effectively reduce the amount of calls that you're doing downstream. One of the additional items that we built in recently is Memcache. This allows us to reduce the amount of S3 calls that goes to the backend to essentially S3. And we can just pull them directly from a Memcache and then render it directly to the client. So on average, a response time with a Lambda going to S3, running on Go, we got it down to between 20 and 40 milliseconds for an average page. And that would be everything from a 20 to 80 kilobyte page. So it's fairly good response time. It's not the greatest in the world, but for most applications, especially single-page apps, that's more than enough. Moving on from this, now that we've had the actual static website hosting done, we started looking at additional items, and we said, okay, we now have static website hosting. What about the APIs on the back end that we used to also use traditional web servers and then used additional applications behind them in order to render the data? So same problems came in. We have ALBs have limits, and we also implemented the same thing. We ended up using gzip. Some of the interesting stuff that we started finding with this approach, and one of the patterns that came out of it, is the co-location of the API server and the ETL job reduces latency and improves security. And on top of this, one interesting thing that came out is we have some secure locations where we basically say, here we run a ETL job, and we're posting the data somewhere, right? But the consuming applications at that time may use an SDK in order to retrieve the data then from the S3 at that time. So what helps from this perspective is our previous page, where you can essentially say, ETL the job runs, it deploys this JSON file somewhere, and you just use our static site at this point that becomes an API server. So it's slightly different from the standard API-driven approach, where it's a post that comes in, you use the Lambda to hit your DynamoDB or your RDS or everything else. This one just serves your data directly. EventDriven Lambda. So what we have for this and in case any of you haven't noticed yet, we have the event-based IRL. IRL is more or less in real life. So this is driven off of logs. And a lot of things that we do see from a logging perspective is sometimes we have a huge amount of logs that do get pushed underneath S3. We do have to grok it. If you look at and I forget the name, some of the grokking systems that you actually look at, they use a huge amount of compute, right? So by using this method, we can basically say whenever there's a change underneath S3, we're going to notify and then execute on it, grok the actual data, add additional information that we need, and enrich the data, and then forward it along. Optimization is also not free, so or image optimization. So this one is something that I'll touch on. I've likely changed this, and we talked about this morning. The reason why I'm changing this is I've seen this a lot at other companies and across the internet. So there's a lot of services that we get across the internet that basically provides us a means to to image optimization, right? And this ties back to our static website hosting, where you may have a 2.5 meg JPEG file. By using this same approach, you can basically say, okay, we've dropped an image file within the S3 bucket. We're going to act on it immediately. So your CI/CD process just dumps it in there. This picks it up. It does an optimization on the image itself and reduces it in size. Or it can actually create multiple different images based on the screen size that you're trying to hit within your CSS, which makes it very effective for a front-end developer. They just have to reference a standardized name, and they'll automatically get all of the benefits from it. And at this point, I'm going to hand it over to Tanu.
Thank you, Will. So far, Will's walked us through overall event-driven architecture. That's a good pattern for serverless, as I'm sure many of you already know. He's also taken us through how we've used Lambda in a few different patterns: static website hosting, API server, and also cloud log processing. Kind of segueing more on the processing side of the house, we have an additional data processing problem related to logs when it comes to, for example, Lambda logs. So if we send Lambda logs to CloudWatch log groups, the problem statement was we wanted to do a couple things with those logs. We wanted to be able to centrally look at them for various reasons, operations, forensics, et cetera. We also wanted to be able to filter them because storing logs has a cost and not everything needs to be looked at the same time. And we also wanted to make sure that we could scan the logs to make sure that only good content was part of the logs. So one of the patterns that we came up with, working with our engineering team partners, is this one. So basically, you have the Lambda sending logs to the CloudWatch log group, and then you can use a cross-account subscription to send that to a centralized Kinesis. Now, subscriptions do support more than Kinesis. Lambda is very popular as well. In our case, though, because we were trying to centralize it, cross-account subscriptions only supported Kinesis. So we have Kinesis there. Now, running on the Kinesis stream, we have data analytics, which can do various parsing and searching and filtering expressions. You could actually also filter using subscriptions before you send to Kinesis. That's a design decision. And then we fire hose it to S3 ultimately for further consumption. And one advantage we saw of this approach is the Kinesis stream is also a consumption point. So we have the real-time consumption at the stream and the batch time consumption with S3. Now, a few of the lessons learned that we had here is with Kinesis, you have a configuration option for sharding. Now, in our case, with Kinesis data analytics and the KCL libraries, we found that true to Amazon's literature, it is really optimal to have one worker per shard. And so we played with the sharding a bit to optimize how many shards did we have for how many concurrent workers we were running in parallel. The other thing we learned is KCL is a library offered by Amazon, and you really do have to keep on top of Amazon's SDK updates. To our chagrin, when we didn't quite keep on top of it, it did cause us issues. So now we try to keep on top of those updates. Earlier I mentioned that we use a cross-account subscription for those log groups. The advantage of that is that it helps us centralize. The disadvantage, though, is we lost the flexibility of being able to use multiple subscriptions on the same log group for different purposes. And the reason for that is quite simply a multi-head subscription does not currently exist. The next type of data processing pattern that we dealt with has to do with using Glue and Athena. So in this case, a couple use cases here. One is basically we had data sets coming into S3. And we wanted to be able to look at those data sets and understand how to classify those data sets. And we wanted to do it autonomously because it was quite a labor-intensive effort to do it through human labor. So we use Glue and Glue data crawlers to be able to help us with this. And Athena was very handy because from a serverless SQL query-based solution, it allows you to query that S3 data directly. And then based on the query output, we could actually create new data sets as needed. So sometimes we call this the S3 sandwich, which, depending on what you're trying to do, you have a different technology in the middle. One thing we learned about with Athena specifically is Athena performance really does vary, and it really does depend on how complex your query is and how well your data set is structured. So for very unknown unstructured data, we found that it really wasn't the best option. Sometimes we would want to format our data properly or put it into certain extensions like Parquet and things like that that made it a little bit easier. The other thing is, from a security perspective, when you use glue crawlers, glue does support iron roles, which is a great thing. However, if you have multiple data sources, there's not really a way to ensure that you have the right crawler crawling the right data source. It's something that you have to either build a process around or tooling around to support. Okay. So this also uses Lambda a bit, but what this example is talking about is, generally speaking, some sort of rules engine. So you basically have some sort of event, for example, from an alerting system like the PagerDuties of the world, and then you want to react to that event. And the reaction to that event may not be very straightforward. You might actually need a conditional workflow around that reaction. So what we did is we used AWS Step Functions to basically deploy a state machine. And based on the conditions of the workflow, we then executed Lambda functions. And then we ended up using DynamoDB to preserve state or past data between states. And this was useful for a couple of different use cases. So one use case, building off the monitoring alert, was self-healing. So basically, an alert comes in. If you're able to define a rule based on that alert, then you can deploy your self-healing automation, and then the incident is fixed before adverse impact. Another type of rules engine, though, is generally speaking policy-driven automation. So if you can define a policy, perhaps a cost-based policy, you want to shut down EC2, or a compliance-based policy, you want to make sure something's encrypted at rest, or a self-healing policy, you want to restart Apache when the condition applies. Whatever that policy is, we found that if you can define that policy and you can define the step functions workflow to accommodate that policy, then this pattern works very well in a serverless way. Now, a few lessons learned that we had is, on the first one, the max input or result data size can be breached. What we mean by that is the way step functions works is when you are, so there is actually a max input or result data size of 32,768 characters. And what that means is step functions actually appends the output of every state to the task execution payload. And similarly with parallel conditions, it actually will duplicate that. So as your payload gets passed along, if it actually goes over that character limit, you can be in trouble. So if you design your step functions with those in mind, then you will help yourself by making sure the number of steps isn't too large or not overly complicated. Similarly, redundant state outputs should use override logic. What we mean by that is, as you pass state conditions to the next state conditions, if there's no significant data useful for the next steps, then you might as well remove the redundant state conditions, because at the end of the day, you are paying for each step. And then we ended up using DynamoDB as our persistent store. Again, the idea behind that was, although the step functions are defining your states, there are times where the Lambda functions need certain data to be transmitted in between them, in which case Dynamo was how we stored the data they needed to reference. All right, and that brings us to our CDN customization pattern. So in this case, using Amazon CloudFront as a CDN, the problem statement was we had some use cases where we needed to either be able to filter some content or rewrite some rules, rewrite some URLs to direct the user to certain places in the application. And so what we chose to do, and this is a pretty well-known Amazon pattern, we chose to custom write rules using Lambda at Edge to be able to provide those capabilities. A few things that we learned on this journey is Lambda at Edge is actually only available in US East 1 for configuration. So from a resiliency perspective, that means that you need to, the control plane of Lambda at Edge needs to be available for you to be able to create them or update them. And just something to keep in mind that's only there in one region. Another thing to consider here is logs for Lambda at Edge. They are written to the same region as execution. So earlier we talked about the CloudWatch log group pattern. So Lambda at Edge will write logs to CloudWatch log groups, but in the region that it's actually executing, which may not be the same region as where your application is actually deployed. Routing can sometimes be complex with Lambda at Edge, and it is a solvable problem, but again, coming back to resiliency and how you think about resiliency and failover, it's a design consideration that you should consider upfront. And speaking of resiliency, one of the resiliency patterns that we had is related to S3. Now, some of our systems that are very sensitive to latency, eventual consistency and a guarantee of that is actually quite important. And because S3 cross-region replication doesn't have a guaranteed SLA, what we ended up doing in this serverless pattern is we actually just use Lambda functions to multi-write to multiple regions, however many regions are needed. So that is good in that it helps the resiliency problem, and it does allow for rolling deployments, but we do hope to overcome this one day. And with that, I'm going to turn it back to Will to talk about how successful scaling can break the things.
Thanks, Tanu. This is an interesting topic, and in previous lives, I actually came from the DDoS world, where we actually did a lot of filtering and traffic and everything else. Whenever you have an application, whether it's a website, whether it's a API server, everything else, and it does get successful, it's a fantastic feeling when it does get successful, right? But the downstream impact that you essentially get from that point in time can be massive. So there is, within Capital One, we have larger accounts, we have smaller accounts, right? We have a fairly big breadth of just accounts in general, depending on the teams, depending on the layout, everything else. How we have structured stuff in the past, where we're moving to in the future. It's the natural evolution of how most companies, I think, work as well. Part of that does impose some issues that you do run into over a longer period of time. One of the big issues here, show of hands, how many has caused impact by having a Lambda function scale way too much? Okay, we have a few people here. So I'm going to touch on this one, right? So you have a application, let's take the static website as an example, right? You have somebody that wants to subscribe to one of the JSON files that you have underneath there, and all of a sudden, it's via a system that does 3 million requests at any given time. Your Lambdas at that point in time will scale, right? So they will take the actual brunt of the load for you, but then they pass it down to the server down below. Now, the server down below, or the backend application in this case, it may be an API gateway, or it may be an actual EC2 implementation that you have that's a ALB or a classic load balancer, or even a network load balancer with EC2s behind it, or even Kubernetes behind it. When you do something like that, these backend systems have to be able to take burst traffic, right? And in some cases, it has to be a huge amount of burst traffic. So one of the patterns that's commonly used and taken into account is to put in circuit breakers, right? If I'm going to get 5 million requests by the same client, all of a sudden, I'm going to rate limit them, right? But if I'm getting 5 million requests from independents, which are not the same client, so it's really not a DDoS attack, but it could be something else, like a bot attack, then we generally lean towards using a circuit breaker in order to say, okay, we think this is probably a DDoS attack, but we're not sure. We're going to err on the side of safety and just circuit break at this point in time, right? And then you cause actual impact for your application, because you're now saying this burst traffic that I didn't expect, I now have to kill all of the items in the backend because the backend can't actually handle the load. Now, some of the additional things that come into play here is, let's say you do run a Kubernetes, right, on the back end, and your deployment that's within the Kubernetes cluster starts scaling out. You have all of your pods go from 3 to 500 almost immediately. But in order to handle that amount of load, your cluster autoscaler at this point in time needs to scale out the amount of instances. This adds several minutes to the amount of time that it's going to take to actually absorb the full load. And while this is going on, there may be additional requests that's coming in. So even more circuit breakers are tripping at this point in time. So it's essentially an avalanche of issues that you're causing that's now breaking the application, and it can cause an extended outage. It sometimes gets to the point where in previous lives, it was easier to just go take the network cable and unplug it from the switch so your systems can recover and then plug it back in. In terms of the cloud, we really can't go and say, Amazon, can you unplug that for me, right? Because it's not possible. So you can still break certain things at a point. Let me move forward, and I'll touch base on something else in a second as well. We've touched on the actual backend application. So whether it's Kubernetes, whether it's another Lambda, whether it's your standard EC2 that touches a RDS database that you max out the connections. Something that a lot of companies do not take into account is what if your Lambda that you're hitting, let's say your backend application does scale effectively, right? And you don't have issues with the scaling. But that backend application uses a lot of AWS API calls. So the impact that you get at this point in time from all of the API calls that get hit is you get limited by AWS at this point because you're using way too many APIs. So then if you're in a fairly large account that has a huge amount of other services that's also deployed within the same account, if these accounts also use AWS API requests, they no longer function. So now you've caused impact, and the blast radius becomes huge, right? Because you have to take into account when you develop these systems, they're fantastic, they scale, they do all of these things really well, but your downstream impact can be huge, and it's something that you do have to take into account. Let's see. Okay. So lessons learned that we've had so far, and I'll touch base on some of the stuff that was there in static website hosting as well. Your security, that usually shifts slightly. And it essentially moves from where traditionally we had the EC2, well, we had physical servers, right? Your physical server had an OS on it. You'd have to patch the OS every so often, kernel updates, vulnerabilities that you need to patch, and so forth. That has moved on to VMs and also EC2 at that point in time. When we look at it from a Lambda perspective, yes, it's a container, but we do not essentially manage the container, right? So the vulnerability patching at that point in time is outside the scope of the developers, and it's now moving to Amazon, which helps us in that front. The problem that we have there is we cannot then say Amazon does everything for us, right? Because it's not true. You still have to take into account certain things. If your application is going to run and you're going to use shared memory, and we touched on shared memory earlier as a caching system, if you're going to put certificates or secure items within memory, you still have to secure it, right? Because in the event of somebody actually running a request and gaining access to that hot Lambda that we spoke about earlier, the problem that you're going to run into there is when it's invoked again, they may have the ability to actually take the data that they've read at that point in time and transfer it off. So your security at that point in time shifts, as mentioned here, to the surrounding infrastructure. How do you allow traffic to flow within your VPC, essentially? So when the traffic comes in and it hits your Lambda, what do you allow outbound? Do you allow it to go just to the S3 server? Do you allow it to go to your API gateway or any other additional service? So you have to make sure that you take into account finer-grained roles or rules at that point in time. The rerun containers we did touch on. It is a problem that's there. I don't think it's as big a problem because most folks tend to not use containers in this fashion, where Lambdas are more or less used as an ephemeral execution environment where it's a one-shot, right? You're running something, you don't expect anything to be stored at any given time. Even though AWS does publish, and they do give us documentation on saying, here is shared memory, you can use it, just make sure that it exists there first. The memory space, we touched on this as well. So please, 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 if you make sure you use best practices. AppSec, if you're using AppSec, make sure you take this into account. We do generally do threat modeling as well. Whenever we build a new application, you go through a threat exercise to basically say, okay, we are on a Lambda, so because we are on a Lambda, how can somebody attack our application, right? If they were to have access to the memory space, what can they do at this point in time? How can they break the actual application? And even if they do not have access to the Lambda application, can they execute certain vulnerabilities because they found out something? And how do we limit the impact at that point in time? Next up on there is essentially the IAM roles can be, or rules can be complex, right? You have conditional-based ARNs, and there's a trade-off for roles versus resource-based policy, and that can be complex. So the next part I'll touch on a little bit more. So managing ingress is much better than managing egress. And so the reason why I say this is let's assume you have 5,000 accounts, right? And within one of the accounts, you would normally grant access outbound, whether it's an IAM policy, whether it's security groups, where it doesn't really matter what it would be. It would normally be your IAM role assumption, or it would be a security group, right? The problem with that approach is, let's say you want to decommission 2,000 of the accounts because they're no longer used for something. Now, because you provided access to, from a role assumption perspective, to allow this system to come inbound, those account IDs that Amazon has, and this is a published pattern, the account IDs get recycled. So if a new customer picks up that new account, they technically could see things that they're not supposed to see, right? So the pattern that we've gotten into with Capital One at this point in time is to basically say, look, we have to really look at this and focus on it. And even if we don't know what the accounts do, we essentially hold on to them just to prevent this from actually happening. There is cases where we actually do recycle them. And this is application accounts where we may do training. So AWS Labs. So we had the Deep Racer event where we were running a lot of different accounts for Deep Racer. We had the Deep Racer Championship that just went through. With those accounts, we essentially had to move our accounts underneath a different org ID so that we can execute stuff underneath there, and it made it very, very simple to just say, okay, when you're done, I don't even have to care about what's there. I can use my SCPs that Amazon provides to essentially lock down the entire account at that point in time. The users couldn't create S3 buckets. They really can't do anything that would provide DLP or anything like this. So it's fully locked down environment. And then once the actual lockdown is complete, the event is over, you just delete it. Same thing applies for when you do something like a labs, right? When your developers have done their training over a course of a week, 2 weeks, depending on how long you allow them to sit within the environment, after that specific time, you get the ability to go and say, okay, let's kill what's there, right? And then make sure that you do not impact anybody else. Let's see. So private networks have trade-offs. So we've spoken about this in the past. We do have private applications. Public API endpoints. So if you are using, prior to 2018 when we delivered the static website hosting, we did look at using Amazon's S3 static website hosting specifically for public items, right? So if you are public at that point in time, you could host a huge amount of stuff through static website hosting, and there's really no maintenance. Amazon just does everything for you. There's some specific items that go missing. So if you do have an Angular application that has a router, and in traditional case, when you have an Nginx where you can do a rewrite-based rule that will rewrite everything back to the index and allow you to have nice URLs, you can't really do that with static website hosting unless you use indexes all over the place, right? So by using a rewrite rule, you gain these things. Those items are unfortunately missing from a CloudFront and from a S3 perspective. Private link is one of the best things that we've seen so far. It essentially enables you within a VPC to allow all of your data traffic to travel over a secure network. It stays within the bounds of AWS's VPC. So you can create a API endpoints as well for S3, for instance. So whereas traditionally, if you create a Lambda, you would still do a SDK call to AWS's public endpoint, right? That means that even though you think you're staying within the bounds of your VPC, you really are still traversing the internet, right? So if somebody manages to actually do an attack and listen at that level, they could still get the traffic. So by using a private link and private DNS resolution, you can keep all of your traffic within the bounds of the VPC at that point in time. So there's really no additional security. Well, there is additional security that you have to take into account, but it's the standard AppSec stuff, right? So it keeps you underneath that secure umbrella. Anything else, Tanu?
No, I think you covered it.
Okay.
Thank you, Will. So just before I summarize our takeaways, we were curious to find out which of these patterns really resonated with the audience. So I'm just going to go back real quick and would like to have a show of hands to help us understand, is this something that you think you would actually be able to use at your day job? So the first one, static website hosting. Who's going to go home and use this? I got a couple. OK, very cool. How about API server? Oh, a few more. Awesome. General event-driven Lambda? This one's popular. Cool. Data processing with Kinesis? Cool. Kind of few. How about data processing with Athena or Glue? Oh, back row. Nice. Rules engine? It's my personal favorite. CDN customization? Awesome. Well, with that, one thing we wanted to share with you is that something that all of these patterns have in common is around their build time. So basically, how do you build them, how do you deploy them, and then particularly, how do you test them? And one thing that we learned is while you can mock certain services and integration points, you really can't get true local development the way you can with non-serverless apps. You really do need that AWS account at the end of the day to support your TDD needs, your test-driven development needs. The other thing we learned kind of, if we look across all of the patterns, is optimizing the deployment architectures. What we mean by that is, at first, it's quite simple to throw up a Lambda function, create a Kinesis stream, et cetera, et cetera, et cetera. But as you look at it over time, some of the design considerations that we've talked about today around cross-account access, around how does your logging work, and then we'll start off talking about observability, which is also the third major point here. It really matters to help you understand exactly how are you deploying your serverless application. What is the impact to any co-located applications, all those backends that Will mentioned, if your scaling is successful? Is it going to be successful for them too, or is it to their detriment? So based on all these different considerations, that will help you design exactly where and how do you deploy. Now, observability, just to harp on this again, with serverless, of course, you don't have your agent-based solutions. So you do want to, from day one, think about how are you going to do your logs, metrics, and traces to make sure you have an observable system. But even more than that, even more than making your particular serverless application observable, it is operating in an ecosystem, right? So you need to think about how do you have that whole ecosystem observable so that you can understand the impact that your app has on other people. I mean, not people, systems. Let's not personify them too much. All right.
So, one additional thing that I'll touch on here, and I get the question very often, right, from a lot of folks across the internet, well, across our ecosystem, essentially, that ask about how do I get into serverless? I don't want to get into it because I don't have anything to test locally, right? And Tanu touched on this. So a lot of the times what I do is I still start with the unit testing, right? if you're doing your unit testing end-to-end, and you're testing for all of the items that's underneath your application, you can usually, in most languages, still write some functional tests as well. That will give you majority of the actual actions and reactions that you would want to have. That way, when you actually do the deployment, you just do a deployment at first for most applications that I've dealt with as a basic just render what's there, just so you can get used to how the structures need to be defined for the ALBs and everything else that's there. The logging side of the world for Lambdas is very, very good. So it will, depending on how you add additional logs within your application, you can really go there and see, okay, when I invoke this function, nothing happened, and here is why, right? And it will usually spell out additional stuff for you, like your policy for IAM does not give you access to S3, or you did not take into account this or that. But it boils down to basically, if you are going to develop something like this, start small. So just deploy something very, very simple that just does essentially an echo. Once you get your echo working at that point in time, then everything else becomes easier, because then it really becomes TDD. Now you can do your entire TDD scope of saying, okay, I created my application, here's my entry point. I'm going to test my entry point the same way I would normally do. From a S3 perspective, almost all of the languages provide us to mock things, right? You can mock a S3 response. So when you do your unit testing, make sure you mock S3. And I'm happy to talk about this more past the session if there's questions about it. It's one of the big things that we did run into, because if you're running a static web host, you have to take into account a lot of different things, right? Especially if you do something like a rewrite rule. If you're doing rewrites that go back to the index, you essentially have to do a head request to S3 first to see if the item exists. If it does not exist, then rewrite it back to the index file. So those are some of the items that you have to take into account. So when you build your mocks, you build this into your mocks to basically say, okay, when I get to this part of the function, I'm going to trigger this, and I want S3 to respond with this actual result, and as it responds with this specific result, I'll do this action. And that's all I got on that topic.
Thank you, Will. And thank you, everyone, for joining us today. It does look like we do have a few minutes for questions. There are a couple mics set up if anybody has questions. I see a hand in the back. Yeah, the mic's over here.
So just a little curious in regards to best uses, or what are people using the serverless for in regards to actual production? So is it airline industries? How are they using it? What kind of data are they using it to correlate, or what processes are they running to keep their, I guess, businesses moving smoothly while taking advantage of the cost that the serverless option or architecture makes available?
I think it very much depends, right? So we went through several of the patterns that's essentially there that we've implemented already. And there's a lot of companies that I've talked to personally as well that essentially do the same thing. They look at it from a file deployed to S3 and then using notifications and a queue to basically work from there and enrich the data or use something within the data. You do have limits, right? We've talked about the limits from an ALB perspective. Some of those limits essentially go away when you're using different systems, but you still have timeouts. So if you're on a Lambda and you're doing data processing on S3 side, you still have to take into account that you have a small time window compared to when you have something like an EC2 server that you can run a compute on a massive file for an hour or two. You really can do that within a Lambda. So it's very contextual. It depends on what your use case is, evaluating what's there, and then seeing whether it can actually make use of this or not. There is a lot of use cases where we do run, we have the ECSs of the world, we have Kubernetes, we have all of these specific things too. So it's an evaluation essentially that we go through an application to basically say, can we make use of serverless? And does it fit within any of these patterns, and how can we apply it? Because the cost benefits, the resiliency that you get, and the no maintenance is massive drivers for using serverless, right? It's not just the fact that you get to say, I do something cool in serverless. Does that answer your question? Good.
Yeah, it's just interesting because with that ability, you have the option to take advantage of those time instances. But of course, now you have to think about the management of that and the back end and constantly monitoring whatever those tasks are. So I'll read up a little bit more, but I appreciate it.
Awesome.
Hey, Suvrat. So serverless at scale might become quite big. How important do you think a CI/CD strategy for a serverless app to be part of your architecture? That's what I thought.
Yeah, I think it's extremely important. So part of that optimizing deployment architecture, absolutely, you need to think about what is your CI/CD from a process perspective, and then also from a tooling perspective, and also from a resiliency dependency perspective, especially considering that a lot of serverless solutions, they don't do multi-region replication. So if you have a multi-region strategy, you need to account for that.
Yeah, I have, two more questions.
Sure.
So, see, we have been doing a lot of serverless architecture deployment on our side. One thing I realize is you probably start with something, but eventually you realize that you have to re-architect, keep improving what you have developed. You might start using Lambda today, but then tomorrow there could be another service which you might want to use. So in your experience, how have you seen those changes in the architectures that you have done so far?
So the benefit that you get with Lambdas, right, is they're inherently small. So because they are small, it allows you to basically say, okay, I found that this specific item that I developed doesn't work. So I can take this small building block that I have and then move it fairly quickly. Some of the stuff that you do have to take into account is essentially DNS, right? So when you deploy something, you use your multiple layers of DNS so that if you decide, I no longer want to use my ALB and my Lambda function, and I want to move this to a ELB and a Kubernetes, that you can actually flip those over. But then what you do have to take into account is, okay, I've now moved to my EC2, how does this impact downstream applications or even upstream applications that may consume the application?
Okay, one last question, sorry. So with CI/CD and serverless architecture, so what essentially has happened with me is I've started using console first, but later realized that CloudFormation, automating your stack with CloudFormation is the important thing for your serverless app to work together. Do you agree?
Yeah, infrastructure as code is very important. We do believe in the power of automation. One thing that I think is still a maturing space, though, is testing for infrastructure as code. So definitely 100% agree with that strategy to automate your build and deploy.
Yeah,
I'll touch a little bit on your CI/CD as well. Some of the stuff that you can get from serverless, right, enables you to make your CI/CD pipeline a little bit simpler as well. So especially if we look at the static website hosting, right, you can create your infrastructure once. You don't have to do rehydrations, right? So you essentially just upgrade your web server as it is whenever you either want a new feature or when you're patching for a vulnerability, right? So then your CI/CD essentially becomes, I no longer configure Apache or Nginx on every deployment. I'm now just pushing to S3. And that is my entire CI/CD. So it does make some things a little simpler.
Yeah, thank you.
Did you have a question?
Yes, I'm sorry, I have maybe a couple of questions. So first question, during your presentation, you never mentioned anything about throttling.
About what?
About throttling, and specifically about API gateways, and generally, do you have any API registry type of capability where you register API lifecycle and cycles of development? It also concerns applications in general. In your organization, do you have any sort of like application dashboard where you register all the life cycles of applications that are currently in production?
So I'll start it off and you can add to it. But we do actually use circuit breakers when it comes to throttling. So we do get to a point where we're saying if we are getting more than X requests that we've baselined for, that will trigger a circuit breaker that then responds with a response to the customer that then says, you have been rate limited, right? And at that point in time, it's up to the actual consuming application to either wait and retry after a certain period of time, but that's basically where we come in with from a throttling perspective.
And it takes time to really establish your baseline and to understand when to throttle. And what we found is if we can incorporate monitoring and testing of monitoring as part of CI/CD, that really helps to establish that baseline and understand when to employ the circuit breakers.
And on top of that, we do a lot of high volume testing as well. So part of it is going to be a performance test that we do run on the application as well. And this is to test multiple different things, right? Can my ALB actually handle what's there if I all of a sudden throw a million hits at it as burst traffic, and how does it react? But then, as I mentioned earlier, you do have to take into account that some of the dev environments that us and everybody else have ever talked to is they don't always necessarily match 100% with what's in production. So sometimes you don't have the same amount of services doing the same amount of traffic, which means if you're doing your performance test in a lower environment, you have to be careful, right? Because you're going to run into the API requests that I talked about earlier, where you impact a larger blast radius than you think you will.
Yeah, and also if you have like hundreds of applications, my second part of the question was relative to registry. Do you register all of the APIs and applications somewhere? And what is your strategy about API management in general?
The short answer is yes.
So yes, it is. So we do use actual registry where we go and register all of the applications. Applications can then onboard to it and then consume from that point on.
Okay. And one more security question. Relative to step function, it's unsecure to store the state. Do you have any sidecar pattern that would store the state in secure locations like S3 or Dynamo?
So if I understood your question correctly, you're asking about storing the state and how to secure that?
Yeah, yes, generally in your diagram, their state itself is not secured, like it's not, at least it's not encrypted, I would say. It's secured, but not encrypted. So as part of financial world organization, do you implement some sort of sidecar pattern when you secure the state?
We do persist state, for example, that pattern with Dynamo, which does support encryption. Mm-hmm. I'm not sure if that fully answers your question, though.
Yeah, you just mentioned that there are a lot of data in the state itself. So I understand there is a persistent part, but there's also state itself stored in a step function instance implementation, which is not encrypted.
I think part of the answer there is since we do threat modeling, right, on every application that we essentially have, we go through that process to basically say, okay, these items may not be encrypted and it's important to secure these items. So how can we change the application? When we look at it then from a finite state machine perspective, it's how can we make the actual steps be okay to be unsecure and then use the actual consumers that's downstream to handle the actual more secure items.
Okay, thank you.
There's a quick question. So you lost me when you were talking about shared storage. Shared memory. I thought everything ran in a micro VM. So, and you were talking as if that would be an insecure or a consideration.
So it's essentially a container, right, that Amazon runs for you. So think of it, I think the easiest way, are you familiar with Kubernetes and how Kubernetes works? Yeah. So essentially when you have a pod that starts up initially, in the Lambda side of the world, right, when that pod is no longer used or the function completes, in the Kubernetes world, it terminates it completely. In the Amazon world, it puts it to sleep, okay? Which means that container and all of the memory segments that it has attached to it at that point in time is then just sleeping. So when it wakes up again, you still have access to it. which means you then have to make sure that if you do store something in memory, that you do secure it, or if it's one of the use cases where it's a very secure system, you have to scrub the memory to make sure that you clean it up.
It's still segregated by a hypervisor.
It is, yes. So you get a container that's isolated just for you. Nobody else on that network can see your memory or interact with your container because it's in AWS space.
Yeah, okay, understood.
And we've got,
20 seconds.
oh, we're over.
Oh, we're over. Never mind, it's counting up now. Okay, we are done. Thank you very much for your time.
Thank you, everybody.